In part 2 of setting up a Docker Swarm, we'll look at adding shared storage to the 3 VMs that we set up in the last video. So we're going to be using a driver called RexRay from EMC, and we're using that because it has good support for VirtualBox. So the first step will just enable the web server so that we have the SOAP API that will be required by RexRay, and we'll set a couple of environment variables. One will be the RexRay server, which will be the manager that we'll choose in this case, and where we want to store the volumes, which will just be in the local directory volumes path. So the first step will be to set up the manager, and here's the main step that you're going to need to do to execute. But for the sake of time, I already executed those 2 steps, and I'll just show you executing basically the same steps on the last node, which is the worker node. So on each of these machines, you're going to go and install via Docker machine SSH. You're going to install the 0.51 version of RexRay, and just make sure that if you're running through this a second time, that you make sure RexRay is stopped and that you've removed any previous configuration files for RexRay. And then go ahead and issue this command to actually create the configuration file. In this case, for a worker node, we're just telling it where the RexRay server is that manages where the volumes are distributed. And then the next thing we'll do is just start the RexRay service. As we see here, we have success. And then RexRay provides a Docker volume plugin driver, so we'll be able to do Docker volume ls, and we should be able to see all the volumes that RexRay has seen, which are essentially all of the disks that are mounted to VirtualBox in this case. So we're going to go ahead and we're going to test the volume setup, and to do that, I'm just going to choose one of the nodes. I'll choose the worker 1 node, and I'll go ahead and issue Docker volume rm, just in case I had previously created the hello persistence named volume, and then right afterwards I will create that driver, that volume using the driver RexRay and giving it a size of 1 gigabit. And then I'm going to go ahead and start up just a standalone Docker container using Docker run and giving it the volume driver RexRay and pointing it to the named volume hello persistence and mapping that into the container's mystore directory. So fast forward it a bit, and you can see that I've pulled a container, it started running, BusyBox, and then the next thing that I can do is do a Docker exe into the running container just to take a look, or just basically to create a my file underneath the mystore volume path. So I'll just do a touch and that creates the file, and then I can go ahead and validate that that file exists in the mystore directory by doing an ls, as you can see here. So what will happen now if I remove that container is that that volume should persist. Let's get the right command here, docker rm-force to remove that running container. And then the next step will be to go to another node or another VM in the cluster. We'll go to worker 2. And from worker 2, what I'm going to do is I'm going to run the same command, mounting the same named volume. And RexRay should be able to, well, under the covers, basically provide that volume to the Docker driver. So no matter what VM I'm on, I can start up a container mounting to that named volume, and I'll be able to basically see the files that I've written to that volume. So this allows us to allow Swarm to go ahead and schedule containers on any node, kill containers, reschedule, and we won't lose any of our data. So there are obviously other drivers other than RexRay. RexRay is one of them. Flocker is another very popular driver that you can use, and there are others as well that work with different cloud providers. So next I'll test that I can see this file by running a Docker 112 service instead of a standalone container. So for that I'll have to target the manager node, and then I'll run the Docker service create command. I'll run one replica of Nginx, for example, in this case, and I'll mount that same named volume hello persistence to the path user share nginx HTML. Docker service ls, just to see that that service has been created. And since this is a service, actually I should do Docker service ps in order to see which node the actual container is being started up on. And as you can see, it started up on manager 1. And if you look at the visualization, it shows that the nginx container is now running on manager 1. And so I can go to the manager 1 node, and I should be able to see the actual container running on that manager node, and it will allow me to do a Docker exec into that container, as I did with the standalone container, and then do an ls inside of it. What you're seeing here is the Docker inspect command. So I can inspect any of these services, and I can show you that yes, indeed, we have the mount to hello persistence. And now, since I'm on the manager node and that's where it was scheduled, I can easily do a Docker exec into that container ID. So I'm going to have to get that container ID. Let's just make sure that I'm on the manager 1 node so I can see that container running. All right, and then I'll just do a Docker ps, and indeed there it is, and here is the container ID. So I'll do a Docker exec with that container ID, and then do the ls of the user share nginx HTML directory. All right, and we see that I have my file as well. So we can see that not only standalone containers, but also other containers, services, etc., are able to actually see the file in the named volume. So now I'll do a Docker volume rm on hello persistence just to remove that hello persistence volume. And when I do a Docker volume ls, we can see that the volume is now gone.